Okay, so I'm a big proponent of building your own ESC or electronic speed controller. If you're going to be using brushless DC motors, you should make your own electronic speed controller because this way you have direct control of the rotating magnetic field. You know phase by phase where you're at in the phases, so your software has direct control of each phase turn of the motor and it can stop it precisely at the right moment. Your software can integrate directly with the potentiometer, which measures the joint angle of the robot. And as soon as that joint angle is correct, it can stop rotating the brushless ESC, but it can still maintain the position that you're at. And this will give you control over how much um, amperage you're sending through it by how you pulse the rotating magnetic field on off switches. You can throttle the amps in order to prevent overheating. Um, you can cause for a more smooth motion with certain tactics. Um, you can have direct feedback through um, back EMF sensing if you choose. Although I think that might be overkill and unnecessary for this type of lower speed application of a brushless DC motor that's not going to be spinning at like drone speeds for flying. Since we're just moving muscles, the relative speed compared to flying is much lower, so I really don't think you need to be able to sense the back EMF, which will reduce circuitry by a lot just by removing that part, and it will save you analog input pins on your microcontroller. Um, it will also save you pretty significant money by being able to build your own ESCs. And another big thing is you might want to have half your ESC on one half of the motor and half on the other half. So like three MOSFETs on one side and three on the other side. So the ESC can straddle the motor and hug tight to the motor in order to take up less room. Whereas if you buy it on a circuit board, a pre-built ESC, it's going to be a much bigger size, and you can't split it up into segments or different parts as you find room in the general vicinity of the motor to fit these different components. You can split up your ESC if you're building it yourself, whereas you don't have that ability when you buy one off the shelf. And so a lot of these reasons, and there's more I'm not thinking of, go into my decision to build my own ESC. And it's really the way to go. Like I said, it's a lot cheaper too, because the total cost of the components to build your own might only be like $2, but to buy a ESC, especially for the really high power output motors, like a 3400 watt motor, you might be looking at hundreds of dollars to buy that, and it would be like $8 in total parts. So you save a ton by building your own ESC. And then another big thing is you can really downsize your ESC by cutting off the little tabs that you normally screw into a heatsink. You can just remove those tabs in order to shrink down the size of the MOSFET significantly. And then you can also attach your own heat sinking solution to it. And I'm going to be using braided solder wick siliconed onto the MOSFET using silicone thermally conductive adhesive. And that will actually be able to glue the solder wick to the back of the MOSFET. And then that solder wick will wick heat away from the MOSFET and bring that heat over to my cooling system, where I'll have the other end of the solder wick wrap onto a copper pipe that has water flowing through it and running throughout the whole robot, and then going to a heat exchange system in the chest of the robot where it passes through a chamber of ice as well as an evaporative cooling air conditioner, basically, which will cool the water and cool the air the robot's going to be breathing. So by building my own ESC, it also enables me to have more fine control over how I'm going to be cooling the ESC, and being able to plan that out more precisely and arrange things in a way that fits into the form factor constrictions that we have when we're dealing with very tight tolerances and very tight spaces. We have to miniaturize as much as we possibly can to be able to fit everything we need to fit. Another cool thing is I'm going to put one LED per MOSFET of the 6 main MOSFETs that drive the motor. And when I run the motor at slow speeds for debugging, I can look at the flashing of the different LEDs to see which motors are coming or which MOSFETs are coming on, and I'll be able to see them, the different phases of the rotating magnetic field that are being sent to the motor by being able to see those little LEDs lighting up. And that will also make the robot look cool on the inside when you're going to have all these little flashing LEDs all over the place as all the motors are working. All these LEDs will be lighting up, and so that would be a cool thing, and you'll be able to quickly get a lot of debugging information if anything goes wrong by certain LEDs not turning on anymore. You'd know maybe that MOSFET's burned out or something. It will give you a lot of clues when you're trying to troubleshoot problems later on. So these LEDs are going to be really nice for troubleshooting. So there's just reason after reason after reason why I really love this idea of making my own ESCs. It's very important, and I recommend that to everybody.